Okay, I thought about making a short video based on very recent events or results that why you should be getting 32 gigabytes of DDR4 memory instead of 16. And with 32 gigabytes I mean 32 gigabytes in just 2 memory sticks, so 2 times 16 gigabytes and not 4 times 8. So the DDR4 era has been kind of different compared to DDR3 days, for example, because back in DDR3 days we pretty much never used single-sided memory, so memory that only has memory chips on one side. Like a very good example of single-sided memory is this Galaxy Hall of Fame DDR4 4800 MHz, so 4800 MHz, 19, 26, 26, 46 timings at 1.5 volts. So this is 8 gigabytes per stick. There are 8 memory chips in total, so 2 tight stacks of 4 chips, so this is the A2 PCB, not the older A0. And the other side of the memory stick is just blank PCB. So the thing about single-sided or single rank versus dual-sided or dual rank memory is that dual rank, so dual-sided memory, is always better performing than single-sided memory. In DDR3 days we pretty much never used single-sided memory. Only at the very beginning with Micron D9 GDR memory chips we did use like single-sided memories, because the Micron based DDR3 memories were often single-sided, so they were 1 gigabyte sticks with just memory chips on one side. A good example of such would be the CSX Diablo memories. These were many of these were Micron based, and the highest bin was 2000 megahertz with 888 timings, but often with very high voltage like 1.9 volts or even 2. So most of the time we use dual-sided memories. So a good example of a better performing option than the DDR3 Microns was, for example, the Corsair Dominator GT 2000-7. So this is a 2 gigabyte stick with memory chips on both sides, which I already demoed in my repair project. So why the amount of viable options during the DDR4 days has been kind of like limited. So DDR4 came out to the market with X99 and Z170 platforms during 2014 and 2015, and all the way since like early 2016 we have been stuck with Samsung B-die based memories. So I'm pretty sure you are familiar what Samsung B-die is. So it's a memory IC which is very commonly used in especially in the high-end DDR4 memory kits. The only counterpart or brand that doesn't use B-dies is only Crucial. Crucial uses Micron based DDR4 memory chips, and that is only maybe the only sleeping giant at the moment that could surpass Samsung B-die altogether. But so pretty much 4 to 5 years we have been stuck with Samsung B-die based memories, but we have been mostly using single-sided memories like the Galaxy Hall of Fame kit over here. And there are 2 reasons for that. The first reason, and probably the stronger reason for the more wide audience, has been the price. So it's much cheaper to get a 16 gigabyte kit, so 2 times 8 gigabytes compared to 2 times 16 gigabytes. So it's a lot more affordable option to get 16 gigabytes in 2 sticks compared to 32 in 2 sticks. And the second reason has been the performance, and now that's the more interesting part. So dual rank or dual-sided memory is always better performing if the performance values are close the same. So dual rank or dual-sided memory is not faster or better performing than single rank memory if it doesn't have close the same frequency and timings. So for example, dual-sided 2666 MHz with 15, 15, 15 timings, that is not better performing than something like this with 4800 MHz frequency and Cas19 timings. That is definitely better performing. So the issue with dual-sided DDR4 memories, like Samsung B-die memories, has been that the dual-sided memories, they generally haven't been able to overclock so well. So even the most high-end options with memory chips on both sides, they have been significantly lower than the single-sided options. So we have had very high frequency options with single-sided memories for a good while now, like 4500, 4600 MHz, and now even 4800 MHz frequency options. And the highest bins with memory chips on both sides have been like 4000, 4133, and now 4266 megahertz, at least from G.Skill in the form of Trident Z Royal. But that bin seems very good, the Trident Z Royal. So 4266 megahertz with 17, 18, 18 timings at 1.5 volts. Now, with the recent launch of the Intel's new LJ1200 socket, so the Z490 platform, some notable guys, for example Dancop and especially Kimpin, very recently have been posting some insane results with dual-sided DDR4 memory. So for example, Kimpin posted a very insane score like 2 days ago or 3 days ago with dual-sided Samsung B-die based memory that absolutely blew off the doors of all the results we have seen this far. He was even able to beat many like Geekbench 3 scores that were done with memories on LN2, so single-sided memories on LN2 with dual-sided Samsung B-die based memories, but everything running on air cooling. So imagine 4900 MHz or close to 4900 MHz with Cas14 timings on a 32 GB kit. That's an insane result, and we can take a more closer look at those scores very soon, but I just wanted to show the example right now. I mean, go through my opinions first. So if you can reach similar daily frequencies with dual-sided memories like that, then there's absolutely no reason apart from the value perspective why you should be getting single-sided memories anymore. Unless, as I already mentioned, the microns, unless the new micron memory chips are significantly better than Samsung B-die altogether, and then we are stuck with single-sided microns once again, or single-sided memories once again. Because at least very recently I saw Alex Rowe from Romania showcasing some engineering sample kit from Crucial with new micron chips. It was 16 gigabytes in 2 sticks, so two single-sided memories once again, but the stock frequency was 5100 megahertz with only 1.45 volts. So, and I think the timings were 19, 23. So unless that is significantly better than the current Samsung B-die offerings, the absolutely best option at the moment to get for any high-end use, it doesn't have to be overclocking, just high-end gaming system would be a dual-sided Samsung B-die option. So there are two reasons when it comes to performance. First is the capacity, so you can get 32 gigabytes of memory in total instead of 16. So of course that is better if you don't sacrifice performance. Memory capacity doesn't matter at all unless you run out of memory. So if the thing you do with your computer never uses more than 10 gigabytes of RAM, it doesn't matter if you have 16 gigabytes of memory or 32 gigabytes of memory or even 64 gigabytes of memory installed in your system. If the performance values of the memory are identical in each case, it doesn't matter at all when it comes to performance that how much more you have installed in your system. If you run out of memory, then you will see a dramatic performance drop. When there's not enough space in your RAM, the system has to write the excess stuff to the hard drive or SSD. That causes a huge performance drop because SSDs and hard drives in general are much slower than random access memory. So you never want to run out of memory, but you don't gain from any excess amounts. For example, when it comes to extreme overclocking or overclocking in general, we always limit the maximum memory that the operating system can read from, let's say, 16 gigabytes down to 4 gigabytes. If we never need more than 4 gigabytes, it doesn't matter if we only have 4 gigabytes of RAM available in the operating system. But when you have 32 gigabytes of 16, I mean 32 gigabytes instead of 16 in a gaming rig, you have much more headroom before you run out of memory. So you have to take that into account. So then you have with two dual-sided Samsung B-die based sticks, you have more room for like workstation use, gaming, web browsing, or just doing all the things at the same time. So for multitasking, so you have one significant gain when it comes to overall use and performance already. So higher capacity. Then you have two dual rank memory sticks instead of two single rank memories. You have much better performance with dual-sided memory sticks. If the numbers are close to the same, so frequency and timings. So why dual rank or dual-sided memory is faster than single-sided is that when one of the ranks is busy, many other things can be read and written from the other rank. So that's so-called interleaving. So some of the memory timings are bound to just other of the ranks, and some of the memory timings are applied on both ranks at the same time. So dual rank memory does have significant performance advantage in some situations. So if those new and the upcoming new dual rank options from G.Skill, for example, if they are very good, then you will not gain, or you will not achieve much better frequencies and timings with single-sided B-die kits anymore. At least what we saw with the Kimpin's result. That's better than most of the single-sided B-dies out there. So unless the price is significantly higher, I don't see any reason to get single-sided B-die memory for a very high-end system anymore. You could theoretically get the same performance with 4 sticks of single-sided B-die memory. So if we had 4 of these Galax Hall of Fame sticks, so then you would have, at least in theory, the same performance as with 2 sticks of dual-sided memory. You would have 4 ranks in total in both cases. But overclocking 4 individual memory sticks is generally harder than just 2 memory sticks. So generally, at least for me, it's much easier to achieve higher frequencies with same timings with 2 memory sticks instead of 4. And with 4 memory sticks, you are always limited to 4 DIMM motherboards. So you cannot use the most high-end motherboard options for the new Z490 platform, like the Z490 Dark Kimpin, Maximus 12 Apex, the Mini ITX options from ASRock, Gigabyte, MSI and Asus, so you get the idea. So that's why I wouldn't really look at those like quad kits, so 4x8. So, but at least in theory you should get the same performance in both, with both options if the numbers are the same, so frequency and timings. And also with, it's much harder to achieve the already so hard command rate 1 with 4 memory sticks instead of 2. So there's also that. Command rate 1 is generally quite hard to achieve with A2 PCB. So it's even harder to achieve it with 4 memory sticks instead of 2. Now when it comes to proper overclocking use, the maxmem, so when we limit the maximum memory, what the operating system can read, it has generally been 2 gigabytes per stick or 2 gigabytes per rank. So if we run, or if we use 2 sticks of single-sided B-die, we have to limit the maximum memory of the operating system to 4 gigabytes or lower. So I'm not fully sure if we used 2 dual-rank memory sticks, could we just use like 8 gigabytes? So then we would have 2 gigabytes per rank, not 2 gigabytes per stick. So I haven't tried that myself because I have never had dual rank BDI yet in my life yet, but I plan to get some now. So these are the opinions why I would get dual rank or 32 gigabytes of memory in 2 sticks at the moment. So let's move on to the desktop. Right now let's take a proper look at the results themselves and then wrap up this video, and definitely give your own opinions down in the comments below, because I think this whole subject is kind of interesting. We haven't really cared about the dual rank options because the performance values or the stock frequencies and timings have been so much worse compared to single-sided options that we have kind of skipped that part altogether. But yeah, let's move on to the desktop view right now. Okay, so taking a look at the actual results. So this was kind of first result posted with dual rank memories in a long time by Dancop, like earlier this past summer, like in June or something. So we can see these memories are running at like 4,650, something like this. So 2323 DRAM frequency times 2, 14, 13, 13 timings, command rate 2, and a multi-score of 10,460. So this is a very good one. With single-sided memories, to break 10K and get near this, you need at least 4800 to 4900 plus with similar timings. So this is a very good result overall. And these are 4000 Cas17 sticks from G.Skill. And these are, at least these are available. The next step bin from these are the 4266, but they aren't really available. I cannot find them anywhere. But very good result. And here is the monster score which I mentioned from Kimpin. So look, made like 2 or 3 days ago, the Z490 Dark Kimpin, 1000K with only 2 cores running to save some heat, because we are running 1.65 on the system agent, so it is just to preserve the CPU, like not to damage anything too soon. A bit under 5.1 gigahertz, but look, 2485 times 2, how much does it is that? That's well beyond 4900 megahertz, closing in on 5 gigahertz, over 4950, 14, 14, 14, 28, TRFC 210. I cannot run this type TRFC on single-sided memories. That's very funny because TRFC should be applied on both possible ranks at the same time. So achieving a very tight TRFC should be harder on dual rank memories compared to single rank. Command rate 2, but doesn't matter for this test. And look, 11,403 memory score. That is absolutely enormous. I have to correct myself on one thing. So this is the highest memory score I ever saw before that score from Kimpin. This is a score made by Ruff. So Tobias from Sweden. 1000K at 6 gigahertz. I think this is from last May or June. And these are with memories running on LN2. So both the CPU and memory is running on LN2, I think. 5200 megahertz. So 5200 megahertz. Very, very high frequency. 14, 14, 14, 28. TRFC of 220. And command rate 2. 11,469. So only 66 points higher than the score made by Kimpin. But this score, so the score from Kimpin, is completely on air cooling. Both the CPU, motherboard, the memory is all running on air cooling. A very insane result. So you can see the dual rank really helps. So the performance is pretty much the same, or even better, or could be better, with significantly lower frequency, over 200 megahertz lower memory frequency, but the same or maybe even better performance. So I'm sure you get the idea right now. Very, very good result overall. So this SPD part number is not correct, but we can see that dual rank. So this is some engineering sample
kit from G.Skill. I think it should be coming in as like 4400 megahertz maybe, or could be the same as the 4266 Trident Z. This is some bulk 3200 megahertz Cash 14 Ripjaw SPD, but doesn't matter. The end figure is what matters. But really awesome result. Then this is like a generic score what you can expect to get with single-sided B die at 4800 plus. So this is 10,338. Even this is very good result. So this is 4950. But this was with 1900K, but they are quite the same. But this is like the absolute best what you can get on air cooling with Samsung B die or single-sided Samsung B die. So much better with the dual rank compared to this single rank. So these figures are quite the same. 10,338 single rank versus 11,403 dual rank. Now Geekbench, you could call that is just some stupid synthetic theoretical benchmark, but it actually gives very good indication on how good your memory is. So if this can get so much higher score, trust me, it will be much better in gaming, workstation use, in everything pretty much. And I also confirmed it from Buildzoid. The maximum limitation is 2 gigabytes per rank. So if you run dual rank kit like this, you only have to limit the maximum memory in the operating system to 8 instead of 4, or somewhere in between 4 and 8. So you have a clear advantage, especially for 3D overclocking, where you don't have to limit the memory so much. So that's very interesting point if you ask me, because for 3D benchmarking, 4 gigabytes is not enough. When it comes to 3D, we often have to use page file to compensate the lack of memory, and that can have, or there's a real risk of clear sacrifice in performance when you have to use page file instead of real available RAM. Now for a comparison, this is like a good comparison what you can get on AMD Ryzen. So AMD Ryzen 7 3800X 2000 well, a bit under 4900 megahertz, like is this 4880 14 13 13 command rate 1, not 2, command rate 1. So memory performance around 8900, so 8900. So this shows that yes, the memory controller can reach, the memory controller of new AMD Ryzen CPUs can reach nice figures, but the performance is worse than on Intel CPUs. That's also one of the reasons why AMD CPUs are so slow in like SuperPi, for example. But these figures are really awesome nonetheless, but just saying. So this is like good comparison on what AMD CPU could get in memory performance when it comes to multi-core. The amount of cores and threads doesn't impact the memory score. So this was only 2 cores enabled, but blows the door in the memory part of the test. So this is the highest bin at the moment which I could find with dual-sided Samsung B die. So this is the Trident Z Royal DDR4 4266 MHz 17 18 18 timings 1.5 volts 32 gigabytes 2x16, but it's not available anywhere. So if we put G.Skill 32 gigabyte 4266, we can only find those quad options pretty much. So we cannot find it at all, and it's not even available on Newegg. And the problem with Newegg is that they only ship to the UK and Turkey when it comes to Europe. So if I wanted to buy from Newegg, I would have to use some kind of a middleman to first purchase the stuff I want from Newegg, and then he or she would send it to me in Finland. The highest dual-sided options are currently from Crucial, but these use Micron DDR4 memory chips. I don't have any experience when it comes to microns. I could try some just purely out of interest. These are of course very expensive, but this looks very interesting. So Crucial Ballistics Max 32 gigabytes 2x16 4400 megahertz 1919 timings, only at 1.4 volts. So very interesting stuff. And the engineering sample stuff was 5100 megahertz, which I already briefly showed you. So that could be the only like sleeping giant to change the game of the entire DDR4 situation at the moment. So if the new Micron chips prove out to be better overall than Samsung BDI, no matter if we talk about single rank or dual rank memories, then the situation could change. But when looking at these figures, I don't really see reason to buy single-sided Samsung BDI based memories anymore, unless the price of dual rank kits is just too high for you. But so maybe the only reason that you may not want to get dual-sided BDI memories is maybe the price. So that's of course understandable, because they are expensive. So we can look, can we find G.Skill 32 gigabyte 4000? There's one example over here. So it's 200 something euros. So 4000 1.35 volts. So yes, not very cheap. And maybe Team Group. So they are generally quite expensive. So that is maybe the only reason. So it's quite hard still at the moment to obtain this kind of kit, but at least that's what I think when it comes to performance. So the price is the only like game changer at the moment, that do you want to get something like this or not. But I'm not fully sure how much difference there is between actual bins. So are the lower end bins good enough to get something like this? Because the only showcases have been with Trident Z's 4000 CAS17 Royals and this new engineering sample stuff. So will be interesting to see, but I will try to get my hands on some dual-sided memory kit, and I hope you will be as well. So let me know down in the comments section below what you think about these scores. I'm sure Buildzoid may make some video of his own about this subject, about single rank BDI versus dual rank BDI, or just DDR4 altogether. But I really think that you should get 32 gigabytes of BDI or DDR4 memory right now, because the values are just so close to each other. This is much better than any single-sided stuff I've had this far. I would definitely trade my best kits for something like this. So just my personal opinion. And it's much more convenient to have 32 gigabytes in 2 sticks instead of 4, because as already said, overclocking 2 memory sticks is much easier than 4 individual memory sticks. But yeah, so if you have any comments about this topic or a subject, then leave a comment down below, and give a like if you like to see this video and hear about my thoughts about this whole thing. And thanks for watching once again, and I will see you on the next one.